Suppose that Oak Avenue is north-south road. So say this is Oak Avenue. And Maple Boulevard is an east-west road. So here's our Maple Boulevard. Okay. So that they intersect at a right angle. So that's right angle. At 1 p.m., so this is picture at 1 p.m. I'll just write 1 p.m. Okay, Adam is 200 kilometers north of the intersection. So Adam is somewhere here. And this distance is 200 kilometers. And he's biking south. So he's biking towards the intersection. And the velocity of him is 24 kilometers per hour. Okay, and Bob is 150 kilometers east of the intersection, so Bob is somewhere here. And he is traveling west, so he's traveling towards the intersection as well. And his velocity is 10 kilometers per hour. That should be hour. I don't know where did second come from. He would be really, really fast if it was second. Okay. All right, so how fast is the distance between the two bikers changing at 5 p.m.? So at 5 p.m., say Adam came here, so this is the distance he covered, this little distance. Say Bob came here, so this is the distance Bob covered. Let me put B over his distance. And we're looking for the distance between A and B. Let's call that as C. So we're looking for how fast the distance between two bikers is changing. So we're looking for dc over dt. And let's remind ourselves, this is a question mark. We're looking for this time at 5 p.m. So they started traveling at 1 p.m. Now we're looking at 5 p.m. So the time is 4 hours, right? 4 hours has passed. Okay, so just like the previous problem, we have to be careful about the side lengths of this right triangle here. If Adam traveled A units in 4 hours, this length of this triangle will be 200 minus A. 200 minus the distance that Adam traveled. Similarly, this distance of this triangle will be, what was this? Bob was 150 kilometers east, so the whole thing was 150. So 150 minus the Bob's distance traveled will be the side of the right triangle. So our Pythagorean theorem will be 200 minus A squared plus 150 minus B squared equals C squared. And I can find the values of A, B, and C because T is 4. I don't have space there, so I'll write it here. T is 4, so Adam travels 24 times 4, which is 96 kilometers. Bob travels 10 times 4, so he travels 40 kilometers. And I'd like to find C, so I can use the Pythagorean theorem I just wrote. So 200 minus 96 squared plus 150 minus 40 squared equals C squared. So that's 104 squared plus 110 squared equals C squared. So we get C equals square root of 22,916, which is approximately 151.38 kilometers. Okay, so now I have A, B, and C values. I can plug them in the derivative of the equation I wrote and answer the question. So let me carry this down here because I'm really running out of space here. This is a longer problem than the others. I won't be able to carry that way. Maybe this way. Okay. All right. So scroll down a little bit. So this is our Pythagorean theorem. I have our values here. So let's go ahead and find the derivative. So bring 2 down. So that's 2 times 200 minus a to the power 1. I don't have to write it. Times derivative of 200 is 0. And time derivative of negative a is negative dA over dt. The negative sign is the same as this one. Plus derivative here is 2 times 150 minus b times negative dB over dt equals 2c times dc over dt. Again, dividing everything by 2, I can get rid of this extra 2 here, which will help quite a lot. So let's go ahead and plug in a, b, and c values. So 200 minus 96, and I'll pull that negative sign here, times dA over dt, times 24. Again, I'll pull the negative sign over here, minus 150 minus 40 times dB over dt, that's 10, equals C, 151.38 times dC over dt. If I do this computation on the left side, I should get negative 3596 equals 151.38 dC over dt, and divide both sides by 151.38. We get dC over dt equals negative 23.75. Again, I rounded up several times, so this is really an approximate value, not exact. Okay, and the units for this is kilometers per hour. Again, we found dC over dt, the derivative of c, to be a negative number. That is because a and b are moving towards the intersection, and the distance between them is getting smaller and smaller in time. That's why the derivative of c here is negative.